Well, first, solve that back.
Six x to the third minus 3x to the second minus 45x equals 0. And the direction is going to say find all the solutions, find everything that will work. The first step for that, take out the greatest common factor, if there is one. Because you always want to take out the greatest common factor. We have been solving quadratic equations, which are x to the second. That's an x to the third. Which means I probably should figure out how to make it an x to the second, which means think about what we have. Maybe something factors out first. Look at the coefficients. Is there a common factor for a 6, a 3, and a 45? What?
3.
See, that's where we're going backwards. And that's okay, because we got to fix it. We don't know what to fix unless we don't know how to fix something until we know something needs to be fixed. Before, when we have denominators and we want to find a fraction, we need the least common denominator. Okay, the one that everything that will reduce all the fractions. And what I hear is the smallest number instead of the one that they have in common. So 5 over 3x to the second, or 5 over 3x plus 2 this equals 1/3 or 1/4. And when I say what's the least common denominator, I hear 3. Or I will hear 15. 4 isn't going to 15. It's got to go into all of them. So what's the smallest number they all have in common? Or if this is a 3, I'll leave it a 3. That's a 6, and that's a 12. So I'll hear 3. Because they're all divisible by 3. If I multiply by 3, yeah, it reduces this one. But a 3 is not going to simplify that completely. A 3 is not going to simplify, I'm still going to have a fraction. So I need the least common denominator, the one that undoes all the denominators. Here though. Listen to the two words. Least common denominator, the smallest denominator that will undo all the fractions. Over here, it's the greatest common factor. The biggest number that you can take out of each one. The biggest number that you can actually divide out of each one. So 6, 3, and 45 are all divisible by 3. I can't take a 6 out of the 3. Can't take a 6 out of 45. I can take a 6 out of 6, but that's not good enough. Okay, I have to be able to take it out of all of it because it's got to be common to everything. So the only thing that divides all of them evenly is a 3. So I'm going to factor out of the coefficients. I'm going to factor out of 3. And then x to the third, x to the second, x to the first. What's the most x's they all can give up? A single x. I can take a single x out of all of them. So I can factor 3x out of each of these 3 terms. So it's 3x times. Don't get ahead of yourself. Just factor out the greatest common factor. And when you do that, remember, you're reversing distribution. So you're dividing out the 3x. When we distribute, you multiply it in, multiplication. So when we factor, we divide it out. So inside, 3 goes into that 6 2 times. And x to the third divided by x to the first leaves x to the second, 2x squared. Minus 3 over 3 reduces, and x squared divided by x leaves x to the first. Minus 3 goes into 45 15 times, and x over x reduces and equals 1. So that's what I have in my parentheses. Step 1, factor out the greatest common factor, if there is one. Maybe there isn't, but if there is one, it makes the next one part easier. If I don't do that, if you go straight to, oh yeah, I want to try to factor like this right away. Think about all the different ways you can make a 6. Well, first of all, x to the third. Well, we probably won't factor that a whole lot. But x times 6x squared, 2x times 3x squared. You have lots of different things to try, not to mention, you try to make an x to the third, and everything that we've done have been x squareds. Solving quadratics. So we must be missing something. So step 1, greatest common factor. Step 2, and remember, telling you, work the problem from left to right, bring it down underneath, straight across, top to bottom. Is this a special factor? Is it a special product? No. Special product, a squared minus 2ab plus b squared. That's not a square. 15 is not a square. A squared plus 2ab plus b squared. No. First of all, that's not a square, and that's not a square. So it's not that special product. A squared minus b squared. No. It's not one of our special products. So now you set up the parentheses. This is a factor. It has to keep coming down every single step. Don't forget it. Don't leave it out. It's 3x. You set up those parentheses. Because you know, we're trying to figure out what factor means. What times what makes this. We're trying to figure out how to multiply 2 binomials together and make 2x squared minus x minus. First thing you do, ask yourself this question. First times first equals the first term. First times first is 2x squared. So what times what would make 2x to the second? The only way to make 2x to the second would be x times 2x. 1x times 2x. X times 2x is 2x to the second. So it has to be an x times the 2x. If you want to put 2x and 1x there, that's fine. You'll still get 2x to the second. But if this thing is going to factor, and if I'm asking you a question where it says solve by factoring, I better give you one that actually factors. And I will make sure it is. So that's the only way you're going to make the first term. So that is absolutely correct. Then you do the signs. For the signs, you look at the last sign. That's what determines what your signs are going to be. And the way you deal with the signs, if we're factoring, ax squared and it's a plus bx and it's a plus c, or if it's an ax squared minus a bx and a plus c. If the last sign is a positive, then it's either going to be, to make a positive, it has to be a positive times a positive or a negative times a negative. So what determines what? The middle. To make a positive here, and the middle in the positive, so we have to have two positives. The middle is made by adding the OI. Outside times outside plus inside times inside for the FOIL. So if they're both positive, these two have to be positive. If you have a negative and a positive, you gotta make a positive. A negative times a negative makes this positive. But then in the middle, these two negative answers will add up to a negative in the middle. That's the only way the signs will work. If your last sign is negative, if you have ax squared plus a bx and a minus c, or an ax squared minus bx and a minus c. Only way that's going to work, last times last is a negative, it has to be a positive times a negative. Last times last is negative, so the signs have to be a positive times a negative. I might end up switching it. It depends upon, do I make the middle? But here's what I know. I know it has to be x times 2x because there's no other way. I know it has to be opposite sides, 1 plus 1 minus. But right away, I'm halfway there, actually more than halfway there. Everything I have is the only way it's going to work. And then the 15. To make a 15, last times last is either 1 times 15 or 3 times 5. And every time I factor, I write down how it's going to happen. What are the pieces of the puzzle that I have to work with? 1 times 15 or 3 times 5. And I write down every single possible way. I don't need to do a repeat. I don't need to go 5 times 3, because I already have it. But I write down all the possible ways, and I start with 1. I don't go random. I don't want to miss it. I want the pieces of the puzzle in front of me. But then, now I'm going to make an educated guess. In the middle, I want -1 of them. -1x. So somehow I'm going to pick either one of these to start with. Which one do you think has the best chance of making -1 in the middle? The 1 and 15 or the 3 and 5? 1 and 15? So if I go 1 and a 15, then you check the OI, outside, outside, inside, inside, and we want -1 in the middle. So outside, outside, x times -15, -15x. 1 times 2x is positive 2x. That's -13x's in the mess. Maybe I switch it, because make that a 15 and make that the 1. 1 times x times -1, (x). Positive 15 times 2x, that's 30x. Well, that's going to be 29x. It's not 1 and 15. So now cross that off, and we're going to try 3 and 5. So if I try 3 and 5. Outside times outside. Positive x times -5, that's -5x. And inside, inside, 3 times 2x, positive 6x. -5 plus 6 is positive 1x. Do I want positive 1x? No, I want negative. I have the right quantity. I got 1x. Wrong sign. So I have the right combination. I just need to switch. Don't switch the numbers. If I trade the numbers, x minus 5 times 2x minus 3. If I switch the numbers, I just messed it up.
negative 3x plus 10x. Different answer. When you have the right amount, but the wrong sign, you switch the signs. Make this one the negative. Make this one the positive. Switch the sign. Because now it's positive x times positive 5, that's positive 5x. Negative 3 times 2x is negative 5 minus 6 is negative 1. That's how I teach this. I don't know the other little tricks and bottoms up and diamond and all that other stuff. If you choose to use those things, as long as you show your work, I don't mind. However, if you're gonna go further, you need to be able to think it through, not just use tricks. Trust me. Trig class right now is factoring this stuff with trig functions. It doesn't work out nicely when you are dealing with sine squared, plus or minus cosine times sine plus cosine squared. It doesn't translate that well with bottomed up and diamond. Now that you have a factor, we're still solving. The question isn't factor it, the question is solve with factor. You're solving for x. Bottom of the box, what is x? So any factor that has an x, you let it equal 0. You let the factors equal 0. This factor has an x. So this 3x could be to 0. Or the x minus 3 can be equal to 0. Or the 2x plus 5 could equal to 0. So when I go to solve this, 3 times x equals 0, what do I do? How do I undo 3 times x? Divide by 3. Don't put x down. It's just divide by 3. And let's make sure we remember that 0 divided by 3 is 0. Okay. 0 in the numerator is 0. And that makes perfect sense. 0 to the third, 0. 0 squared, 0. So 6 times 0 minus 3 times 0 minus 45 times 0, 0 minus 0, all 0. 0 is the solution. 3. This x is even to 3. And here you have to subtract 5. And you get 2x equals that negative 5 divided by 2. And we get x equals negative 5 over 2. This is why your test doesn't have any questions from 2.1 or 2.2. Solving linear equations. Because you're solving linear equations right here as part of 2.4. So write your final answer. Negative 5 over 2, 0, and then 3. Why did I write them like that? Yeah, because why don't we put them in order? Numbers actually have a built-in order from smallest to biggest. Smallest number to the biggest number. It's like the letters come in an order, alphabetical order. Why? Because somebody put them that way. It's like, at least numbers have an order because it's the greater than less than I get. Is C greater than A?
I don't, it's like, who put that order together? Why can't we go A, W, X, F, K, who says? I guess somebody did. That's English for you, right? That's any kind of language. Arbitrary. If you don't put it in that order, I'm not gonna take off points, but make sure you list each one with a comment. All right. Number two. Number two doesn't have any mandatory direction. It just says solve. That is exactly how it's gonna be when you see this question on your test. It's not gonna have any direction except solve. You're gonna get the review sheet today. On the review sheet. 3 problems we have to solve by factoring. You're gonna only have 1 on your test. 3 problems we have to solve using completing the square. 1 on the test. 3 problems where you have to use the quadratic formula. 1 on the test. And then 6 more, or 7 more problems. Right here, number 16. Looks just like the next one we're gonna do. You have a perfect square and a number. When do we use the square root method? This method is used to solve an equation with a perfect square and a constant. X minus 5 perfect square plus 16 equals 0. A perfect square, 4x minus 5 to the second, and a constant. Square root method. And I'm emphasizing this so much is because, again, it's a freebie. It's really, it's easier than you want to think it is. And I do this every semester because nobody listens to me. Maybe if I stop emphasizing, maybe you can just figure it out for themselves. I feel better when I emphasize. What the mistake will happen is, because you're used to doing this all the time, they'll try to FOIL that out. They want to multiply it all out, convert it to this so they can use the quadratic formula for everything. That's going to be a mess. First of all, when they try to multiply this out, they don't multiply it out correctly. When they combine the right terms, they don't do that correct. They make a step, wrong step, or they make a bad calculation somewhere along the way. Or it's a perfect square and a number. We isolate the constant. Subtract 16 from both sides. Parentheses, 4x minus 5. This is a perfect square equal to negative 16. You take the square root of both sides. Don't forget your plus and minus. Keep saying it. Square root of 4x minus 5 squared is just 4x minus 5. Square root undoes the square. Equals. Don't forget the plus and minus. Plus or minus. Square root of a negative. Poke out the I. What's the square root of 16? 4. So plus or minus 4i. Now you solve for x. So to solve for x, you're going to add 5 to both sides.
And you need to put the 5 in front of the 4i. Can you combine a real number 5 with an imaginary number 4i? Can you actually combine them together? No, they're different kinds of numbers. So you're going to get 4x equals 5 plus or minus 4 times I. And then to solve for x, you divide both sides by 4. So x is equal to, let's talk about it. You have to simplify your final answer to lowest terms. Now, here's what you can simplify. If you can add or subtract things, you need to add or subtract. If I could actually add 5 to the 4i, I would have to keep going, and I can't. If it was 5 and just a 4, there was no I here. If this was a positive 16, this would just be a 4, so I could actually add the 5 and the 4 together. But I can't because it's an I. So I don't have to add the 5 and the 4. If I can factor and reduce something, I need to do that. Here's what you don't want to do. Don't think you can just cross the 4 off. You can't just cross off the 4 because you have to have a common factor for all 3. So to simplify this, you either need to factor first, then reduce, or here's the safe way. Split the fraction, then reduce the individual parts. So you either need to factor out a common factor. 5, 4, and 4 have nothing in common. So this is fine. You can stop right there. They have nothing in common. If they do, you'd have to go further, but they don't. Or if you want to play it safe, x is equal to, if we split the fraction, 5 over 4, and then plus or minus 4i over 4. Now you can reduce individual fractions. 5 over 4 does not reduce, plus or minus. 4 over 4 does, so it's just plus or minus I. That would be possible. But you can't just cross things off up here. You can't just go, hey, that. Because the answer is not 5 plus or minus I. Because if you cross off the 4, then 5 has nothing underneath it. It has to be multiplication. It has to be factored before you do it. So you either split it, and that's the safe way, or factor first. X squared minus 8x plus 5. Complete the square. This is what we did on Tuesday. So there's our step by step. So. Step 1. Isolate the constant. What's the constant in that problem? 5. So we isolate it, we're gonna move it over to the right side, so we have to subtract 5 from both sides. And then it has a little reminder. Leave an open spot where the constant was. X squared minus 8x, leave that empty space. And over here, a -5. That's where we're gonna add something that is gonna complete a perfect square. Then step 2. Make sure A is a 1. You're gonna check the A, which is the coefficient of your square term. It has to be 1 times x squared for us to keep going. If it's not, you divide all the terms by whatever that A is. So this is 1 times x squared. So we're good to go. You can keep on going to step 3. In the fourth question, A is a 4. So we have to do a little bit of work before we can move on. Step 3. This is where completing the square actually takes place. And like I said on Tuesday, it's like following a recipe. You take half of B. B is the coefficient of your x to the first. B is the coefficient of your x to the first. So what is B over here? -8, including the side. So I always write it over here on the side. 1/2 of -8. There's my half of B. What's half of -8?
4.
-4, sign matters. -4. So we take half of the B, that gives us B over 2. Then you're going to square it. Then I go parentheses, and I'm going to square it. A negative squared is a positive, and then 4 squared, I get 16. So I take half of B, which is -4. Then I square that answer, I get 16. And then I take this and I add this to both sides. That's why I have that open space. $11. You have just completed a perfect square triangle that is ready for factor. That step right there makes a perfect square on the left. A perfect square that will always factor into A plus B perfect square or A minus B perfect square. So we can take the square root of both sides. So this left-hand side is a parentheses squared, over there we have 11. What would make x squared? It would have to be x times x. Last times last is positive, but the middle's negative. So what would the sign be? We need a negative times a negative. They get a positive here and a negative in the middle. And then what times what gives us 16? 4 times 4, and in the middle, a -4 and a -4 make a -8. But I said on Tuesday, this is why I write the half of B, square it, add to both sides. I write the half of B over here on the side. Nice little coincidence when I do the half of B. It will always be right there, sign included. It will always be right there for us. And that's why I go to the trouble of actually writing out word for word, half of B. And then right there, -4. That's what half of B is. Then I square it. And there. Okay. Now, if you don't see it, you can do it by hand. You have to factor this. So you go, all right, I mean parentheses. X times x is x squared. Last times last is positive, but the middle's negative. The only way we're going to get a positive here and a negative in the middle has to be negative, negative. And then 16 is either 1 and 16, 2 and an 8, or a 4 and a 4. Which of those would make a negative 8? Would a 1 and 16 make an 8? Would a 2 and an 8 make an 8? No, 4 and 4 would make this 8. And you have x minus 4 times itself, which is x minus 4 squared. But you don't have to do that because it's always going to be one of these two, because you did step 3 right. Take the square root of both sides. Simplify, don't forget your plus and minus. Square root of x minus 4 squared. Plus or minus. Nothing's breaking out, square root of 11. Solve for x, add 4. You can't add 4 because nothing breaks out of square root of 11, so the answer is positive 4 plus or minus the square root of 11. You leave your answer just like that. There are two answers. If you split them, it would go x equals 4 minus square root of 11, then comma 4 plus the square root of 11. Or minus it, or plus it. And then on this last one, here's why we need the last bit of lecture for today. Because sometimes you get a little whiny. And like. So far, the only ways we have for solving equations like this. Factoring, completing the square. So if I want to factor that, I got lots of ways to make 4x squared. There's going to be lots of ways to make it 10. So I'm probably not going to want to try factoring right off the bat. If I decide to do completing the square, well, then I would isolate the constant. Completing the square would always work, by the way, but look at what you have. Then you got to make sure this is 1x squared. So you would have to divide everybody by 4. So x squared minus 3/4 x. Always simplify. 2 times 5 over 2 times 2. This is 5 over 2. It has to be 1x squared. So we're stuck with those fractions. If you undo the fractions, we're back to a 4x squared. We can't do completing the square with that 4x squared. So now you got to take 1/2 of b. Half of 3 over 4 is negative 3 over 8. Half of negative 3/4. And then when you square it, you get positive 9 over 64. And then we probably go, you know what? I really don't want to complete the square. I hope there's another way. And that's part of today's lecture. Quadratic formula. But the quadratic formula doesn't exist unless we have completed the square first. With the quadratic formula, if you can identify A, B, and C, then all we have to do is, first of all, you gotta know the formula. And plug in A is a 4, B is -3, and C is -10. Plug it into that formula for A, B, and C and simplify. But you gotta know it by heart. No notes. Tattoos, I don't consider notes. So if you have a tattoo of it, it has to be a real tattoo. Okay, when I was a baby, my mom used a Brillo pad for my back. So I'll have a Brillo pad just here to make sure, it doesn't wash off. I'm serious. Yeah. That's how we grew up. Or I think she was just. Yeah, anyway. But that's where we're headed for today. Okay. Come back again.